Hello, Autonomous Nation. So this is just a little introduction to the Sooner Rover team and the autonomous subteam. So first of all, just what is the Sooner Rover team? If you don't know, we are an engineering competition team where we create a Mars rover prototype that we then take to compete in international competition called the University Rover Challenge. The University Rover Challenge is also known as the URC, and it's in Utah, and we get to compete against other rovers and other teams from universities all around the world, and it's really cool. So what is the autonomous subteam? So we're the autonomous subteam, and basically what that means is that URC is separated into several missions, and one of those is the autonomous mission or the autonomous challenge, where the rover does some tasks, which we'll talk about later. But the difference between the autonomous mission and the other missions is that for all the other missions in the URC, you're controlling the rover through remote control, where you're sitting like in a van and you can see cameras for where the rover is, like what the rover is seeing, and then you're using a remote control to control its movements and its behavior. But in the autonomous mission, we don't get cameras and we don't get remote control. We just have to run code and the rover has to go and do things on its own. So, sort of going more into what that mission entails, we'll just sort of do an overview of the autonomous tasks. So, the first task in the autonomous mission is just simply driving to a GPS coordinate. Technically, it's a GNSS coordinate, but that's just a fancy way of saying GPS coordinate. But in this section, they give us a series of GPS coordinates or a single GPS coordinate, and we have to just sort of enter that into our code, run it, and then the rover needs to automatically navigate to that coordinate, stop within a certain distance, and flash its lights to indicate that it's arrived at its destination. The next section of the autonomous mission is finding ArUco markers. So this is very similar to the GPS part, where we get coordinates and the rover has to navigate to those coordinates. But instead of just navigating and stopping, those coordinates are within a 10 to 15 meter radius of an ArUco tag, which is sort of circled there on the screen. An ArUco tag is just kind of like a QR code, and each of these ArUco tags is associated with a given number. So the rover has to navigate to that coordinate, and then because it doesn't know exactly where this tag is within the radius of the coordinate, it has to sort of figure out some way to search for the tag. And then once it's found it, it needs to stop within a certain distance of it and identify it. So finally, we have the object detection part of the autonomous mission. So this is very similar to the ArUco marker part where we're given a coordinate. We don't know quite where this object's going to be. We just know it's near the coordinate. But in this case, instead of looking for an ArUco marker, which sort of has a more distinctive kind of appearance, we're actually having to do image detection to identify a specific object where they one of the advantages is they do tell us what the object will be ahead of time. So we do have that advantage, but it's still, more difficult than having to find a QR code. So why should you join Rover? For one thing, it's really good on your resume. Companies love knowing that you're part of a competitive robotics team or just a competition team in general, because it builds a lot of really important skills like, teamwork. So the sort of questions that people ask you about in interviews are like, okay, what was a time where you were working in a team and you had to do this and this or whatever? Rover's really great for being able to answer those sorts of things, being able to get some experience. And we do a lot of serious programming in the autonomous sub team in a lot of different languages, including like Python, Rust, C, and even things like JavaScript and TypeScript on the front end. You also get to learn about ROS2, which is a robotics framework that is kind of a standard in the robotics field. So if you're interested in robotics, it's a really cool thing to get to experience. And it's also just really fun. It's just a really fun thing. Going to competition is a blast. And it can even like be something that pairs well with some of the courses here at OU. We even have like the intelligent robotics course and the computer vision for autonomous vehicles course. Both of those use ROS, which is the robotics operating system, which is what we use for Rover too. So, there's some things that sort of tie in with other experiences that you might be able to have. And those courses could help you with Rover, or Rover could help you with those courses. But as I said, competition is really fun. It's personally my favorite part of being on the Rover team. We get to go to Utah and go and like it's this long road trip where we have like half of the experience of competition is just the 2 days driving there and the 2 days driving back. And it's something that is really fun. You really get to bond with the other members of the team. We like to go to the quote unquote beach, which is a river that's in Utah. We, do some hiking. We typically kind of stop some tourist destinations. And the overall experience is also just like, it's sort of that thing where it's like, it's kind of stressful because we're trying to get these tasks done and we have a limited amount of time, but it's like type of stressful that is also like fun at the same time because you're doing it with your friends and you're doing it, you know you're getting to see your work pay off, which is really neat. So in conclusion, is SoRo fun? Yeah. It's pretty neat. It's a good way to just kind of learn about things, and hopefully this was helpful in just sort of introducing what the autonomous subteam is and what the Sooner Rover team is. So thank you very much.